Hello and welcome to the AICE Chemistry lecture series. In this video we're going to cover section 5 of chapter 7, which is going to focus on some simple vocabulary. We're going to look at oxidizing agents and reducing agents and what those terms means when they're applied to a redox reaction and the half processes of reduction and oxidation. So let's start it. Oxidizing agents and reducing agents are going to just be some specific vocabulary that we use when it comes to things that are getting reduced and things that are getting oxidized. An oxidizing agent is a substance which removes electrons from another substance, therefore oxidizing that other substance. So essentially, an oxidizing agent is something that removes electrons by gaining those electrons, by adding electrons to itself, meaning that it is going to decrease in oxidation number itself. So some typical oxidizing agents are things like oxygen, chlorine, potassium permanganate, or potassium manganate 7 being the Cambridge term, and potassium dichromate. What these things are things that they themselves get reduced. And this is a very important idea and an easy way to remember this. The term agent means that whatever we are speaking of is undergoing the opposite process. So an oxidizing agent is something that is getting reduced itself, but it's oxidizing something else. And that's because the process of oxidation is the removal of electrons, while the process of reduction is the gain of electrons. For a chemical to remove electrons from something else, it needs to itself gain those electrons, meaning it is going to be reduced itself. So oxidizing agents oxidize other things, but they themselves get reduced, meaning their oxidation number is going to decrease while the oxidation number of the thing they're interacting with goes up. So again, some typical oxidizing agents that when you see them in a reaction, you should automatically kind of flag them as oxidizing agents are things like oxygen, chlorine, potassium permanganate, which, if we remember our nomenclature, is going to be KMnO4. And when we're talking about oxygen or chlorine, we're talking about O2 and Cl2, as well as potassium dichromate. Potassium dichromate is K2Cr2O7. So other than chlorine, one of the things that you will notice about a lot of the oxidizing agents is that a lot of them have oxygen in them. Oxygen obviously is an oxidizing agent. Potassium permanganate has 4 oxygens. Potassium dichromate has 7 oxygens. A lot of things that are strong oxidizing agents are going to have a lot of oxygens in them because they're oxidizing or adding oxygen to other compounds. And so with that logic, reducing agent is the exact opposite. A reducing agent is a substance which donates electrons to another substance, therefore reducing that other substance. A reducing agent itself gets oxidized. The oxidation number for the oxidizing agent will increase because when it donates electrons to another substance, it reduces that other substance, but it itself gets oxidized. So that's, again, a very important idea here, is that the word agent is going to mean that whatever process we're talking about, the agent gets the opposite process. So if something's a reducing agent, that something gets oxidized while it's reducing something else. Some typical reducing agents are going to include chemicals like hydrogen, and again, we're talking about hydrogen gas here, so H2. Potassium iodide, so Ki, and reactive metals like aluminum. Once we get to organic chemistry, we'll see some other very common reducing agents like NaBH4 is another one, as well as NaAlH4. These are some other strong reducing agents that we will see in organic chemistry once we go into later chapters. But aluminum, so most reactive metals, potassium iodide, hydrogen are also very strong reducing agents. These are all chemicals that tend to donate electrons to something else, getting themselves oxidized and therefore reducing that other compound. Now, these are not necessarily mutually exclusive. Certain compounds, like hydrogen peroxide, can act as both oxidizing or reducing agents depending on what they're paired up with. One of the things that you'll notice about hydrogen peroxide is that you have both oxygen, which makes it a good oxidizing agent, and hydrogen, which makes it a good reducing agent. It's because if you notice, a lot of the chemicals I wrote earlier have a lot of hydrogen in them. And so because of this, hydrogen peroxide can act in both ways. If we look at this example here, it can act as an oxidizing agent whenever we react it with iron 2+. When this reaction, iron 2+ goes from +2 oxidation number to a +3 oxidation number, meaning that the iron 2+ is getting oxidized as its oxidation number is going up from 2 to 3. On the other hand, if we look at the oxygen here, let me grab another color, the oxygen is going from -1 in hydrogen peroxide, because remember this is one of the exceptions for oxygen. When in hydrogen peroxide, oxygen has a -1 oxidation number, to -2 in the product side. So oxygen is going from -1 to -2, meaning its oxidation number goes down, it itself getting reduced. Because the peroxide has the element that is getting reduced, it is acting as an oxidizing agent. On the other hand, if we look at the reaction of hydrogen peroxide with iron 3+, again, very similarly here, iron 3+ is going from a +3 oxidation number to a +2, meaning now the roles are flipped because we flipped the ions of iron. Here, iron 3+ is getting reduced, going from 3+ to 2+. But the oxygen in hydrogen peroxide is going to go from being -1 here in the peroxide to being 0 oxidation number for the O2. Because remember, elements by themselves have 0 oxidation number. So here, the hydrogen peroxide is going up in oxidation number, meaning it's getting oxidized. So because the hydrogen peroxide has the element, oxygen, that is getting oxidized, it is a reducing agent. The hydrogen peroxide is essentially reducing the iron 3+ in this scenario, but in this top one, the hydrogen peroxide is oxidizing the iron 2+. And so hydrogen peroxide in this case can act as both an oxidizing or a reducing agent depending on which type of other chemicals we combine it with. And that's again because of its particular stance where you can have, it has both hydrogen and oxygen in large amounts. So now that we have this vocabulary down, let's look at a sample practice question. And this practice question is very much about vocabulary. If we look at it, aqueous bromine reacts with methanoic acid to form hydrogen bromide and carbon dioxide gas. And they give us the equation here. The table shows the oxidation numbers of bromine and carbon in the species involved in this reaction. So they're actually nice enough here to give you the oxidation numbers in this reaction. We don't have to apply them ourselves because that's not the focus of the question. Here they tell us oxidation number of oxygens of bromine is 0, that the carbon in HCO2H is +2, that the bromine in HBr is -1, and the carbon in CO2 is +4. Then the actual question reads, identify the oxidizing agent in this reaction. Explain your reasoning with reference to the oxidation numbers. So here this is a 1-point question with 2 different command words. So we have a 1-point question here But there are two different command words we're working with. The first is identify, and the second is explain. Meaning that you need to both identify, so you need to identify the oxidizing agent, but you also need to explain why that's the oxidizing agent with respect to oxidation numbers. Meaning your explanation should include their oxidation numbers on what they tell you. So if we don't do one of these, if we identify the correct chemicals, but we don't explain why this is the case, we will not get this point. So here we can see, if we look at our oxidation numbers, that the oxidation number of bromine is going from 0 to -1, as they told us, meaning that the bromine is getting reduced because the oxidation number is going down. And then the carbon is going from +2 to +4, meaning that its oxidation number is going up, meaning that carbon is getting oxidized. Here is where it's important to know your vocabulary really well. The question is, what is the oxidizing agent? Not reducing agent, not the thing that is oxidized, the oxidizing agent. And if we remember, the word agent means the thing that is getting the opposite. So the oxidizing agent is getting reduced. So this will be the same as asking which of the compounds is getting reduced. So here the answer, we have answer up here, is bromine. Br2 is the oxidizing agent. And be careful with what you write here. Not Br, not HBr, but Br2, because the oxidizing agent has to be one of the reactants. Br2 is the oxidizing agent. And the reason why is that the oxidation number decreases for Br2, meaning it gets reduced, or it oxidizes the carbon. So we need to explain, but notice how I didn't just say it's Br2 because it's getting reduced, because the question says in reference or with reference to oxidation numbers, meaning I need to include the oxidation numbers in my answer. In fact, instead of just saying the oxidation number decreases, I should and could really say the oxidation number decreases from 0, because I have the specific numbers, to -1. Now, not every mark scheme will be that detailed where you need the exact oxidation numbers, but it is a good habit to get into, because writing that does not take you that much longer, maybe a few seconds. And here's what we get. Br, or bromine, as the oxidation number of bromine decreases from 0 to -1. So you can see here how we do have a specifics in our mark scheme. We won't always have that, but you want to have it if it's in the mark scheme. And since you don't know what's in the mark scheme, I would always recommend to err on the side of caution, meaning write what you have here if it takes you only a few more seconds. The other way you could have written this is that bromine is, as it causes the oxidation number of carbon to increase from +2 to +4. So instead of talking about what happens to bromine, you could say it's bromine because of what bromine does to carbon, meaning that bromine is oxidizing the carbon, which is what we wrote here on the second line. So there's a couple different approaches to how you could answer this that would make sense. The important part here is getting the right chemical, making sure that you mention the oxidation number changes and being specific if you're able to, and making sure that you're addressing the fact of what either that bromine is doing or is what it's undergoing. All right? That is it for section 5 of chapter 7. I will see you in the next video to talk about how we can use these oxidation numbers to name some compounds and why some of those Cambridge names that we use in the exam are different from what we learned in honors chemistry.